next built-in type to discuss in Python is the byte array type. It is very similar to the bytes type that was just previously discussed, except that it is a mutable or changeable sequence of integers representing bytes, typically from something like a string. On the left of my screen, there is the typical Python shell where I will run my program. On the right, we see the program ByteArray_demo.py. Let's run that with the run menu, run module command. At the beginning of the module, we find 5 different ways to construct a byte array object. You could create an empty array with that byte array function. You could create an array that will be filled with nulls. If you use byte array and an integer, there will be 11 elements initialized to a byte value of 0 or a null value. You can also specify the bytes that you want in the array as a sequence of integers. So using the byte array constructor function with those integers, we'll then create an array of them. Similar to the bytes type object, you can initialize your array based upon an existing string that you have and the encoding that that string is in. And finally, you can also create a byte array object based upon a bytes object. In this case, a literal bytes object is used to create that bytes array. So in the first printout, we see the way that a byte array is represented with byte array parenthesis and then what looks like a literal bytes object. Like the bytes object, it does have a decode method, which defaults to UTF-8. You can also specify the decoding format that you want to use. In this case, it decodes to trademark with that registered trademark symbol. Byte arrays are like bytes in that they're similar to the way that strings behave. You'll find the same kinds of methods, only when you apply those methods, instead of referencing a character, you reference a byte value. So whether you specify a character capital T for a string or hexadecimal value 54 for a bytes array, you'll have the same effect of counting the capital T, which there's one of those. You could also index the position of that capital T, either within a string, like 0 for the first position, or index that by the byte value of a capital T, which again is hexadecimal 54. And again, within the byte array, it appears in the first index position at 0. Now, what makes the byte array objects special is their mutability, or the ability to change them with methods. So in this example, we have several methods to add on or remove elements from the array. With the bytes array append method, you could append a single byte where the byte value 32 represents a space. It's a little hard to see in the printout, but there is a space right before the end of that string here. You could also extend a bytes array object with multiple bytes. In this case, those 2 bytes that represent the one single registered trademark symbol are being added with the extend method. And so we see those 2 additional bytes encoded in hexadecimal. When you use decode method on a bytes array, again, you could see how that might be represented in UTF-8 as the registered trademark. By using a remove method, we're able to take that byte out of the array. Remember, hexadecimal 54 was the capital T. After that's executed and we print the object again, you can see the capital T is no longer present. You could insert at a specific position, in this case at position 0, add a byte with hexadecimal value 54, would reinsert that capital T that was previously removed. With the pop method, it will normally remove from the end of the string. Although not demonstrated, you could use an argument to specify the index position that you want to pop off. So by using pop twice, the last 2 bytes were removed from the string, which removed essentially just that one registered trademark symbol. You can see that when we print out the decoded version of Bytes Array. So by this demonstration, you should now know how to work with the Byte Array object and understand its similarity to the Bytes object and to the string object as well.